Just like in other programming instances, you're going to have lots of pieces of information that might be bigger than a single variable. So you want to group that data together under a single variable instance. Well, one of the ways to do that in C is with the array. If you've ever programmed before, it's very similar to arrays in any other language, in that it is a continuous and sequential set of information, all of the same type. So, for example, you could make an array that holds 5 int values, one right after the other. The way that you declare an array in C is with the data type that's going to be stored within it, the name of the variable, a set of square brackets, and within them, how many of those pieces of information you want to store. So this line of code creates an array of ints called myArray that can hold up to 5 ints. You can fill up your array with information using this notation, where you're both creating the array and filling it up all in a single line, where the items on the right-hand side are going to be placed in that exact order into the array. If you want to access the information that's stored in your array, you reference it by the name of the variable instance, a set of square brackets, and then the index of the item you want. Each item within the array has an index, and in C, the arrays are zero-based indexing, meaning the very first item in your array is not at index 1, like we humans maybe think, but at index 0. So in our case here, that number 1 is actually at index 0. That number 2 is at index 1. That number 4 is at index 2, and so on and so forth. So even though we have 5 spots, the 16 is not stored at index 5, it's stored at index 4. You can also replace whatever is stored at a certain index using the same notation to access a specific index of your array. Now be careful. Because an array cannot grow or shrink once you've made it, it's just a set block of information, if you try to access an index that does not exist, you're going to get an error that will crash your program. This is called a segmentation fault. And it's a pretty common mistake to make. In this case, it would be a pretty simple mistake to assume that because you store 5 items in your array, that there must be an index 5. But there's not, remember, because of zero-based indexing. So this line of code here would cause an error. If you want to group together pieces of information that are not the same, you can do that with something called a struct. This is somewhat related to what you might call an object in another language, but it can only really handle individual variables that you're grouping under a new name. And you can sort of think of this as creating your own data type. The way that you construct a struct is with the keyword struct, and then you come up with a name for your new data type. In this case, we're making a student struct. Then a set of curly braces, and then the list of variables you want to all be associated with this new data type. These are called the members of your struct, and you can have as many as you want, and they can be whatever type you want. Once you have declared the blueprint for your struct, you can create new versions of it in your code with a line like this, where you use the keyword struct, the name of the struct that you came up with yourself, and then an instance variable name for this specific version of your struct. So in our case, we're creating a struct to hold information about students in general. And if I'm working with students, maybe I want to know their name, their first name, their last name, how many credits they've earned so far, and what their overall GPA is. Here on this line, I've created a specific instance of student 1. Now I can go in and use that instance variable name dot the name of the variable stored within the struct and specifically access it and fill it up. This is called the member accessor, and you can just individually set each of these variables, but they're all stored under the same name, which makes organizing your code way easier. This is very similar to any other programming language. The only difference here is that string copy method is how you would go from a string to an array of characters like we have listed here in our struct. C is not an object-oriented language, so you can't do too much with structs and arrays, but for our embedded system purposes, it's more than sufficient, especially because we're going to be collecting lots of pieces of data, but they're probably going to be pretty simplistic pieces of data. You'll want to figure out how to group them appropriately using either an array or a struct.